All right, we're going to take a look at damped trigonometric functions. Now we can have a damped trigonometric function when we have a function that is multiplying, or a function, how should I say this? Yeah, by multiplying a function to the sinusoidal function. So we have two functions in one function, 2 in 1. All right, so here it says identify the damping factor f of x of each function. Then use the graphing calculator to sketch the graphs of f of x, negative f of x, and the given function in the same viewing window. And then we're going to describe the behavior, specifically the amplitude of the graph. Now, here we have a function, y equals 5x times the sine of x. Well, our damped factor is this function right here, 5x. This is the damping factor. This is the f of x being multiplied to the sinusoidal function. And so what we're going to do is we're going to graph the sine of x, and then we're going to graph 5x, and then negative 5x, which actually helps us when we graph the f of x and the negative f of x, helps us see the damping effect of this function here. Now I've got here how I set up my scale in my window settings for this particular function. If you're following along, and you should want to try this on your own, I set the x minimum at -10 for this particular damped function. X max at 10, I used a scale of pi over 2, and then my y minimum is -50, y max at 50, and the scale of 1. And I'm going to do this particular one on the graphing calculator, and we got two other examples after that, but I'm just going to show you the viewing window in the graphing calculator as we graph the damped function, and then we're going to describe the behavior. All right, well, here we are, and you can see how I set my window settings up for this particular one. Everyone's going to be different as far as the window settings. We got x minimum of -10, x max of 10, x scale of pi over 2, y minimum -50, y maximum 50, and a y scale of 10. Let's go in here and graph these functions. So first we've got 5x times the sine of x. And then we're going to graph the damped factor, both first as just 5x, and in my case, since I've got y3 set up to an inequality, I'm going to go to y4, and that's going to be -5x. And let's go see what this graph looks like. So our damped function is going to be in blue, the positive 5x is going to be in red, and the negative 5x is going to be in pink. There comes the blue, the damped function. All right, well, look, cool. Now, what about our amplitude? What's happening with our amplitude? As I'm going out here towards, as x is approaching negative infinity, what's happening to our amplitude here? Well, we can see that it's increasing going out to negative infinity, and it's increasing going out to positive infinity. And I could come from the other way too. What if we said what's happening as we are approaching 0 from the right and the left? What's happening to our amplitude in that direction? Well, it's decreasing. So depending on how I'm viewing this, we can then determine what our amplitude is. So let's go with the 0. As we are approaching 0 from the left, our amplitude we see is decreasing. That blue is getting more narrow. And as we are approaching 0 from the right, well, we see the same thing, that our amplitude is decreasing. All right, so here we go. We're looking at another damped function. Our damping factor this time is this function here, or the reciprocal function, 1 over x. And we're also going to graph the negative 1 over x. So we can see our damping effect on this sinusoidal function of the cosine of x. Now this time, here's the scale that I used in my window. I set the x minimum at -3 pi, the x maximum at 3 pi. We had a scale of pi. And then on the y-axis, we had y minimum of -2, y max of 2, and a scale of 1. And let's see, what about as we are approaching, well, this time let's do it as we are approaching negative infinity, what's happening to our amplitude, and also as we are approaching our x equals infinity, what do we see our amplitude doing? Well, we see that it is, would you say, decreasing? Because here in the blue is our factor. Yeah, we're decreasing as we're going out to plus or minus infinity. And then our third example of a damped trigonometric function, well, guess what? This time we got an exponential function. So our damping factor is the f of x is equal to 3 raised to the power of x, and then we'll also use -3 raised to the power of x. We see that in pink. 3 raised to the power of x is in red, and our total function here, 3 raised to the power of x times the sine of x, is in blue. And the scale that we set up on the x-axis, we set negative, hard to see that negative right there, but it's there, -pi/4, 9 pi over 4 as the x max. We used the scale of pi over 4. And then on the y-axis, we used -320 to 80 with a scale of 40. How do we want to describe the amplitude? Well, it's definitely decreasing as x is moving towards negative infinity. And it gets really, really, really small. Here's a big amplitude out here like this. All right, there we go. They look cool anyway. Lots of fun.